We just finished the first section, which was deploying your first app. We went through Scaffold-ETH. We went through kind of the build guild and building with Scaffold-ETH and Speedrun Ethereum. Now, this is what we ended up with was our counter. Yeah, how's it going? Cheers. Okay, so we ended up with this cool little county counter. This is what it looks like on localhost. We were able to build a simple smart contract that kept track of a count, and then a simple front end. We use Cursor to deploy the front end, and there it is. We can increment our counter. So the last little piece to do if you're deploying any app will be to put it out on a chain like Arbitrum. So I'm going to do yarn deploy -- network Arbitrum, and that's going to tell me something like I need to generate a key store. So I'm going to create a new one. I'm going to enter a bad password. Oh no, that's a key store. Oh, that's the name of the key store. I want to generate one. I don't know. I don't know which key store I used. Basically, it does this thing where it encrypts local passwords. Let's see. I bet it's that. Oh no. What am I sitting here doing? Okay, there we go. Okay, so we're going to deploy this on Arbitrum. It looks like it's deploying now. There we go. So I was able to deploy our counter app to Arbitrum. It's just a simple county counter that probably cost me like a fraction of a cent to deploy. Okay, now you need to make one change. Like after you've been working on localhost, you've got your front end, you've got your smart contract, you've looped that a while and worked on it. Once you have this and you deploy it to Arbitrum or some other live network, you need to get into your scaffold config and tell it to point the front end at Arbitrum. There we go. No, not Sepolia. We're going live. Quit using test networks. That's my hot take. Don't use testnets anymore. Testnets are worthless. The infrastructure is terrible. Just deploy to like an L2. It costs a fraction of a cent. Costs a fraction of a cent to use it. I made 1,000 transactions on Arbitrum the other day in like the matter of a minute or two, and it cost me $1.80. So don't worry about finding a faucet for a testnet anymore. Just start using L2s. Okay, so now with this one change where we changed our chain on Scaffold-ETH, it was, if you look over here right now, it's connected. Oh, wait. We want to use burner wallets too. Let me do one more thing so I have a burner. No. I don't need burner wallets. Let's go live. Okay, so now our app is on Arbitrum, and there is the live contract that we've deployed to Arbitrum. There is our contract on Arbiscan. We still need to verify it. But let's connect my wallet and let's go increment our counter on chain. Let's actually like pay real money to increment our counter on Arbitrum. Okay, here we go. Here is county counter on Arbitrum. I'm gonna click the button and pay real money to increment a counter from 0 to 1. Hooray. Okay. So very simple code here. Of course, these are just starter apps. We're going to dive into the speedrun now and cover a much deeper set of concepts. I'm going to kind of like gloss over a bunch of builds, and then we're going to have Kevin and Shiv get up here and actually deep dive on the stablecoin and then the prediction market. So I'm going to speedrun like the first 6 challenges here. We won't actually write code. Now that we've seen how to like deploy an app, oh wait, let's put it out on IPFS too, right? Once we've basically seen how to deploy the smart contract, that little IPFS thing is going to put our front end out there. So now that we've seen how to deploy a single small app using Scaffold-ETH, what kinds of things do you build? Now that you know how to build an app, what kinds of things, like what do we build, right? And that's where we move over to Speedrun Ethereum. So Speedrun Ethereum has a ton of builds, and this is what you need to do as you become more well versed in building with Solidity. You're going to get to the point where you're like, okay, I know how to build smart contracts. I can do it. What do I do now? And the thing that you need to do is build a whole bunch of things. You need to build a whole bunch of things, and you need to put them on a real network, and you need to try using them. And then you need to get to the point where you're building your 8th and your 9th and your 10th thing, and you're starting to get users who actually try your app. The goal should be build something that someone's going to use, right? The goal of all of this is building something on chain that is decentralized, that lives forever, that's tamper proof, that other people will use, okay? So what kinds of things are people using? Let's start from the top and come back the other way, right? ZK voting, prediction market, stable coins, over-collateralized lending, a DEX, a dice game, a token vendor, a staking app, NFTs. Let's speed run those now, okay? So what people use smart contracts for a lot, one of the most simple things is just like a canonical record, like a place where you can go to get information. Maybe it's just like a hash of a repo. We were just talking about releasing software packages. Ethereum is a great way to track software releases. If you wanted to have like a Git release and a hash for a certain package, you could totally use Ethereum for that. Create a smart contract where a multisig or some wallet can sign a Git hash and then put that on chain. And then all your users, when they go to pull down your code, they just have an extra verification step where they go read from Ethereum what is the hash of this package and compare it to the hash that they have and make sure that they're getting the right code when they download it, right? So just creating a canonical record. Attestations are another big thing, just like using ECDSA key pairs to sign some information and attest to something, and then you have some aggregated attestations that come together to give you reputation and information about people or something. Then the other thing is like credentials, right? And that's where this NFT challenge starts, is you can build credentials with non-fungible tokens. You can create a token that says Kevin owns token 1, Shiv owns token 2, Shiv sends token 2 to Charlie or whatever. So another really good use case of Ethereum is creating credentialing and then like token gating or using those credentials for reputation. And you'll do that in this first challenge, is you'll deploy these little Buffalo credentials, and we're kind of changing it up. NFTs are a little bit of a bad word these days. The NFT craze is behind us, and so is my net worth. But we've kind of moved on from NFTs, so I like to call them credentials now. But moving on, I think one of the most important challenges of Speedrun Ethereum is this staking app. Basically, what you're trying to do is it's a massive multiplayer game of people who don't trust each other. And you're trying to get them together to coordinate. And if you can imagine, if we had to get everybody in this room together to go buy a car, we could all chip in the money, and maybe you could trust me and I could go buy the car, right? So when you have that central point of trust, it works for a small amount of people. It works at a small scale. But at some scale, at some point, trust breaks down. And that's the point of Ethereum, is it's meant to be trustless. It's a platform where code runs exactly how code is written, and you only have to trust the crypto economic system will hold up. And we went and looked at that WETH contract earlier with $9.5 billion in it. There's a lot of bounties to break this system, and it still works. It's actually been up for 10 years without any downtime. So when you deploy an app here, it'll always be up. And anyone can get to it, and the code will never change, and it will always execute exactly how you built it. So this staking app is to get a bunch of people to coordinate together to purchase something. And in this case, it works kind of like a state machine. When you're building your first contracts, you sort of realize that it's kind of like building a state machine. You have this deposit state that we're in at first, where we're allowing anybody to deposit funds into our contract. And then, oh no, that's not good. Let's get on the Wi-Fi. Oh no, the Wi-Fi is down. I might have to tether to my phone. Let's go back. Can I have that? Okay, just stay there. Don't click anything. This staking app means that we want to get a bunch of people to coordinate together that don't trust each other. So at some point, this trust breaks down. Let's say massive multiplayer, we're trying to get not just the room full of people together to buy a car, but we're trying to get 1 million people together to buy a country or an island, right? If we were trying to get 1 million people together to buy an island and we're all pirates that don't trust each other, we need some system of trust between us, right? And there's always like an escrow idea where like maybe we trust some third party, but let's pretend like we don't trust anyone. We're pirates, right? And we want to buy an island. How would a million pirates buy an island? Well, they would probably use Ethereum. They would use some kind of decentralized system where it's trustless and there's just a smart contract. And the smart contract is the state machine. It has this deposit function and it says, hey, every pirate in this group, in this DAO, whatever we are, the pirate DAO, you all need to deposit some amount of money, right? Let's say every pirate has to deposit $10,000 and we're gonna go buy this island. So every pirate needs to deposit their money, and we write the smart contract that says any pirate can deposit it, and then at some point you have to poke it and move it into either the withdraw state or the success state. So the state machine needs to transfer from deposit to either withdraw or success. And nothing is automatic, right? When you think of DAOs and decentralized autonomous organizations, it almost sounds like something is automatic there, but nothing is automatic on chain. Everything has to happen with a transaction. To make something automatic though, this is really interesting. You think of maybe like running a cron job on a machine, right? You have some server, the server runs some cron job every night, or maybe we set up this staking app and then at night or at the end of the staking app, we need the server to complete, right? That server can fall over. Even if we have multiple servers throughout the world, those servers can fall over. What you need is a system that is as resilient as Ethereum, something that has been up for 10 years with zero downtime. And so to create some system like that will make sure that this staking app moves to the next round, the trick comes down to incentives. Incentives are really important. Basically what you do is you build your smart contract to say everyone can deposit funds, and then at some moment in time, anyone in the world can poke this smart contract. Anyone can make the transaction, and whoever does it gets paid $100. And so you have a whole world of people incentivized to push that button, and whoever pushes it gets paid for it. And when they do push it, it moves us into the next state. So you kind of have this state machine that makes its transitions through these incentives. And this is a really kind of interesting insight into how you build smart contract apps. So let's say we've all deposited, we get to the point, someone pokes it, we move into the next state, and basically when someone pokes it, there's a little piece of code that says, have we collected enough money? If we've collected enough money, then we're gonna move into a success state, and that money is gonna go buy the island. If we didn't connect enough money, we need to move to a withdraw state. This is the important part, right? If people, pirates, who don't trust anyone, have staked their money into this contract and we weren't able to get enough money to buy the island, we need to go back to a withdraw state and all the pirates need to get their money back. And pirates like stealing money from other pirates, right? So if there's any way you can lock someone's money up or steal someone's money, they're gonna try to do it. And you need a system that does not allow that. You need to write your smart contract so no one's money gets locked up. And if we're not able to coordinate, everyone can withdraw their funds. So at worst, they stake their funds, they fail to coordinate, and they withdraw their funds. No one loses their money, no one's money gets locked up, and that's your job to write this staking app, and that's the first challenge on speedrunethereum.com. Then there's a token vendor. You'll deploy an ERC20 token. You'll build a second smart contract that sells that token. So then you can kind of set a price in your smart contract for what someone would pay for that token, and then you sell that token to people at that price. And this was kind of like the ICO craze of 2017. People were making, millions of dollars in 15 seconds, by selling an ERC20 token. This is now getting like speedrun, where now these cycles for pump and dumps are happening in like 2-hour phases. It's definitely like a race to the bottom, but tokens have a lot of also interesting value. And if we forget pump and dumps for a little bit and we look at real world assets and tokenization, there's a lot of really interesting things happening in the world right now with tokens, but also some garbage and some pirates and other things. Now, let's say you want to make a game. When you want to make an on-chain game, and first of all, like sometimes when I talk about on-chain games, I like to say you may not want to build like this fully featured game universe. When you're building games on Ethereum, you may want to think about just building like an inventory system or a module system or some small reusable module that anybody else can build. And that's kind of the beauty of building on Ethereum or on a blockchain that's public, that's open source, is any little module you build and deploy, anybody else can extend and use permissionlessly. They don't have to ask you permission to borrow your inventory system. They don't even have to go to your GitHub and fork it. It's already on-chain working, and they just use it. Now they could like go fork it and use it and change it how they want. But a lot of times when you build a module and put it on chain, like Uniswap v2 is beautiful. It's this cool swapping system. It's really easy to see and use. You can go build a smart contract on mainnet right now where you just send a little money to a contract that goes to Uniswap, swaps it to a stable, sends a stable coin back. Beautiful modularity, super clean. You don't have to go ask Hayden from Uniswap's permission to use it. It just all works, right? And it works, by the way, through Liquidity, which we should talk about in a second when we talk about the DEX, which is a fun kind of rabbit hole to go down. But we're talking about the dice first. If you're trying to build a game with randomness, it's kind of tricky because you're on a public deterministic blockchain. It does exactly what it's programmed to do. It does exactly the same thing every time. So there really isn't any randomness. You can imagine all these validators all over the world running this code. They can't each get a different random number, right? They're all going to get the exact same thing. So to do randomness, it's kind of tricky. There are ways like you can go to an oracle and get VRF. There are ways to do a commit reveal. But a lot of people kind of do this lazy thing by using the previous block hash. And that's what happens in this dice game is there's a game, you can pay to roll the dice. It uses the previous block hash to get a random number, and then if you get a certain value, you get paid back. Well, what's tricky about that is you can actually build an attacker contract, and that's what you'll do with this dice challenge. You'll build an attacker contract that only rolls the dice looking at the block hash if it's going to win. So there's this dice game, and you build an attacker contract that allows you to only roll if you're going to win. And you'll get in there and you'll figure all of that out pretty quickly. Okay, so now we move on to the DEX. This is where we're starting getting to interesting territory. I think this is the title of this talk. Building a DEX is definitely your kind of your awakening moment into getting into Ethereum. A DEX is what has been coined by Jacob from Zora as a hyperstructure. So a DEX allows you to swap two tokens. Before a DEX, if you wanted to swap token A to token B, you had to go to an order book system or over the counter or some kind of escrow. Something there was centralized. With an order book system, it was still settling on chain in a smart contract, but what you would do is you would sign a message that said, I want token A, I have token B. If you give me 10 token A, I'll give you 10 token B. And you sign that and it goes into a centralized order book. And then someone comes along and makes that trade. They take the signature, they put it on chain, they send in their tokens, you get their tokens, they get your tokens. Pretty cool that you can swap tokens, but it's centralized, right? With that centralized server, it has all the problems of a centralized system, being it can be censored. Someone can decide not to let you swap those tokens, and it can fall over, right? The actual server that's holding those can fall over and quit working. And these two kind of key things are why you want to have a decentralized system. You want it to always be on, and you want anybody to get to it at any time and no one to be able to censor them. And so building a decentralized version of this exchange is kind of tricky. And the way that they figured out how to do this is by providing reserves of both assets loaded up in a smart contract. So to make it available for you to swap from token A to token B inside of a smart contract, you need to have reserves of both of those tokens. So we'll have 100,000 token A's and 100,000 token B's in that smart contract. And then when you want to swap, imagine it like a little scale. See that little scale on the screen? You put in some token A and it kind of tilts the scales. So what you have to do is use this constant product, y x ky xy equals k, something like that. You'll get in and figure out the constant product thing. But imagine it more like this. You put in some token A and you got to take out some token B to equalize that ratio again, right? So you put in some token A, it gives you back some token B. And that's how this works, is basically there's reserves of both and there's a ratio between those two, and that ratio stays the same. And as you put in one token, you get back the other token. And that's how a DEX works. Now, these reserves are really interesting, right? How do you get all these reserves in this contract? And the trick comes back to incentives. Incentives are this really powerful thing that kind of go with blockchain really well. We see like the crypto economics of what keeps a blockchain secure have to do with incentives. That's how this app works too. Basically, when anybody makes either of those trades, a little bit is left behind for the liquidity provider. So whoever the person is that provides this liquidity, whoever puts these reserves in, they get paid just a little bit every time someone swaps. And this is a really interesting concept. So if you're thinking of the person who deployed the DEX, this DEX is just the hardware, right? It's just a vending machine that sits there empty at first, right? You deploy it and it's an empty vending machine. And anyone could come along and supply the liquidity for it, right? Not just one person either. Millions of people can all supply a little bit of liquidity, and the more liquidity, the better the swaps. And then other people could come along and swap between those two tokens, paying a small fee, and those liquidity providers earn a little bit by having that liquidity available. So everybody kind of is incentivized and happy using this system that you built. And this is what you do as a smart contract developer. You build these vending machines. You build this system where people can coordinate that don't trust each other. And in this case, you swap different tokens around, and you just wrote the rules for people to use this system. Liquidity providers come in, they put in their tokens, and other people come along, pirates come along and swap their tokens back and forth. They get the token they want. The liquidity providers get paid in incentives with a little bit of fee that gets left behind. And you, the deployer, you just built the hardware. You just built the thing and it does what it needs to do. And so that's the kind of thing that you're going to be building on Ethereum. That's the idea behind a hyperstructure. And that's what you'll see when you go to build your DEX. And you can do that at speedrunethereum.com here in challenge number 4. You can go build your own DEX, and it's going to take you through how to build a DEX. It sounds like my flight is coming. Okay, so after you finish that at the Build Guild, we have onboarding batches. We bring you into a Telegram group. We teach you how to make a PR. We teach you some Git etiquette. We give you some more challenges. We even have like a smart contract that we deploy, and then you deploy a smart contract that withdraws from that smart contract. Is the audio okay with that going on, or should I hold up? Everything okay? Okay, cool. I'm just gonna keep going, talk over the thing. Okay, we have this kind of like hands-on onboarding batch that happens at this point. So once you've gotten this far, you can kind of join us and we'll try to help you get into the space, find internships, find a job. The real critical part is after you've gotten to this point, you just need to build a whole bunch more things and actually put things on mainnet, put things on L2s, and just build a bunch of things, and then you'll start to get noticed by other people and get hired in this space. But we have some kind of complementary, like extra hard challenges that we'll go through. And I'll talk about over-collateralized lending next. And then Kevin will go through how to build a stablecoin, which kind of uses over-collateralized lending with an Oracle system. And then we'll have a prediction market from Shiv, which is kind of like deploying 2 tokens with the promise to rug one of them for the other one. It's kind of a fun build. Okay, so after you've gone through the building a stake, building a credentialing system, building a staking system to help pirates coordinate, building a token vendor to sell a token at a certain price, building a game with some randomness using commit reveal or something better than previous block hash. Once you've built a DEX, you've figured out how hyperstructures work, you understand how to build a token swapping mechanism. The next thing to build would be an over-collateralized lending system. And this is where DeFi really starts to shine. We've got tokens, we can sell them in a contract, we can swap them between token to token using this DEX system. but lending is this really powerful mechanism. Lending is the kind of thing that's behind all this other, it's kind of like gambling, right? Like perpetuals and everything else. All of that is happening because people are leveraging up. Basically, they're taking a token, they're locking one token up, they're getting an over-collateralized loan for another token, and they maybe even loop that, where they take that token, swap it back to the other token, put it up as collateral, get a loan, take that, swap it back, collateralize it. That's how leverage works, okay? But it all comes down to this really simple pattern of lending, and the way it is, it's over-collateralized lending. So what you do is you lock up some ETH, maybe let's say $200 worth of ETH, and then you get a loan for some token, right? But you only get like $150 worth of that token. It's over collateralized, right? You've got more money locked up in the system than you have loose in what you've borrowed, okay? So I've got $200 locked up in the system, and I've got $150 of tokens to go play with. I'm gonna do something with this stable coin. Who knows what I'm gonna do with it. I could do all sorts of fun things in DeFi, but I have some token and I'm going to go use it to do some things. And then when I'm done, I can bring that token back and I can get my $200 of ETH back. And the way this system works is the over collateralized, as long as the money in the protocol stays over collateralized, everything is good. You have $200 locked up here. You can take the 150 and do whatever you want with it. But what happens is if this 150 ever starts getting worth more than this, like if the price of ETH goes down enough that your $200 is now worth $150 or even $140, then the protocol is in big trouble because they've given you more money than they have and they're going to go bankrupt, right? So the way you build this protocol is you say there's some ratio, this collateralization ratio between how much they've lended out and how much they have in collateral. Hey, look, there's a pigeon. Get him. Woo, woo. Okay, this is cool. We're in this giant room here in New Delhi and a pigeon just landed with us. pretty sweet. Okay, so you've got $200 locked up as collateral. You have $150 worth of a token, and all of a sudden the price of ETH starts to go down. What do? Well, the platform needs to be built in a way where it liquidates the collateral. The person already has their $150 worth of tokens. The only thing you have control of is the collateral that they've locked up in your protocol. So if you want to create lending, you want to allow people to do this thing where they lock up money and get another token and go use it somewhere, they leverage it up, they can do all sorts of speculative, interesting things with this mechanism. If you want this mechanism to work this way, basically you need over-collateralization, but you need a specific mechanism of liquidation. Just like we were talking about earlier, where nothing is automatic, you have to poke it. Someone has to come along and poke the thing, right? So what happens is, there's always this collateral ratio. There's this ratio of the 150 tokens you've taken out and the $200 that you have locked up. If the price of this starts getting closer, let's say it goes down to 180 and 170, right? It's getting close to being 150. You cannot let it get down to 150, right? If you ever get to the point where the collateral is worth less than what you've given out, your platform just lost money and you can't do that, right? So what you need is a system where no matter what, someone pokes the button and does the liquidation. And basically they sell the collateral to cover the costs of what people have borrowed. So $150 went out, $200 got locked up, but the $200 of ETH is slowly worth less and less. By the time it gets to 175, there needs to be a function in the smart contract that says liquidate. And that sells the 175 to cover the 150 and then pay the person that did the liquidation. This is the important part. Again, back to incentives. If you want to make sure that this liquidation happens, your platform needs to pay someone to do the liquidation. And that's like how you guarantee that your platform never loses money, is you never let that collateral get worth less than what you borrowed out to someone else by having this liquidation mechanism. And you do that by having someone be able to liquidate it as it gets close, and they get paid to do the liquidation. They get maybe like $10 of that collateral, right? So it's at 175. You sell it off. 165 covers the 150 that was loaned, and the person gets an extra $10 for running the command, and it runs no matter what, right? What you have is a platform where tons of people are watching it all over the world with tons of different servers, and they're always trying to run the liquidation on people. And if you get lucky enough to liquidate someone, you get paid the money. So it kind of sounds like you're the bad guy who's liquidating it. But this method actually like keeps the platform whole and makes the protocol work. And this is just a good insight into the kinds of things that you build on Ethereum and how you go about building a system that works in a decentralized way. Okay, so that's basically the whole speed run. We went through Scaffold-ETH, we built a little counter, we started with the smart contract, we wrote a little smart contract that just incremented a counter. Then we moved over and we wrote the front end. I used Cursor to do that, which is really nice. Scaffold-ETH does that with Cursor really easily. So you're able to, with like a Cursor rules, kind of just tell it, like you can one-shot apps, which is really neat. It's, of course, still a little dangerous to be one-shotting a smart contract app. You probably shouldn't one-shot a lending platform that's gonna have like $1 million TVL or whatever. You should kind of like maybe do audits and make sure you know what you're doing with the code. But if you're a good coder, AI is just going to 5x and 10x your work. So you can get in, use Scaffold-ETH, you can vibe code or code up a smart contract, you can vibe code up your front end, and you can have a smart contract app very quickly. You can use this debug contracts tab to tinker with your smart contract, and then you can deploy it live. We put this app out on Arbitrum. So this was just a simple counter app, but my colleagues are going to come up here from the Build Guild and they're going to go through a much more advanced app. We'll do stablecoins in a little bit and prediction markets. They're going to use Scaffold-ETH the same way, and all of this will be built on Speedrun Ethereum. So I think that's basically all I have. I don't know how much time we have left. I don't know, maybe we could do questions if anybody has any questions before we get into the deep dive of stablecoins.